Okay, ladies, we're going to try and just move forward a little bit with this lesson on multiplying polynomials, and we will finish up the last part of it tomorrow. So I don't know if you have your paper with you, your handout, but what we did, just to remind you, is we put on the outsides. This is when you get the outside here. Those are the dimensions. For B, we did this in class. So we did an x here, and then we did plus 3. And then we had 2 x's here, plus 1. And then what we did, if you want to put the plus 1 here, you can, or the plus 3 there, you can. Then we figured out what had the dimensions that were there. So what is x by x? An x squared. And I'll kind of highlight these as we go. And then what's x by x? Another x squared. Then moving up, what's x by 1? It was an x. Now moving over, I had something that was 3 wide, but x tall, so that's going to be 3 x's. Again, 3 wide, but x tall is going to be 3 more x's. And then 3 wide and 1 tall is going to be 3 little babies. Then if you write what the inside is, to remind you, that's the sum. That would be, I had 2x squareds, I had 7 x's, and I had 3 little ones. It's okay if you didn't get super far, so I'm just going to kind of go through and show you these, and if you do have your paper with you, you can kind of check your work. On C, 2x times the quantity of x plus 5, so you can see I have 2 x's on the outside, and then I had an x and 5 here. Sorry, don't mind my dog. And so that's when we ended up with 2x squareds and 10x. On the next one, I had 2 x's plus 1, and then 2 x's plus 1. And that gave me 4x squareds, 4 x's. You can see 2 of them here, and 2 of them here, and then 1 little 1 in the corner. And then I'll just go through these too. So x times 2x plus y would give you 2x squared plus xy. If you got this far, that's the answer for F. 2x squared plus 2xy plus 9x plus 5y plus 10. And on these, when you have more than one variable, don't worry about standard form. On the other ones, you might have noticed I started with the x squared, and then I moved to the x, and then I moved to the constant. And then you can see g and h there. Again, you might not have gotten this far in class, and that's totally fine, but those are the answers for you. Okay, so what I want to look at next is the highlighted problems. Do you see any patterns? And hopefully, I remember 1 or 2 of you started to notice this on some of your papers when I was walking around. You actually had the answers to some of these already written out, like that one I saw, and on this one I saw on one person's paper before they had done it. And hopefully what you're noticing is when you have a problem like this, where it was just one thing on the outside, that you might remember from your days in 7th grade, that we can actually use the distributive property. So 2x times x, let's make this bigger, 2x times x, that's going to be 2x squared. And then 2x times 5 is going to be a positive 10x. So what we're going to be building on here is the distributive property. Now with this isn't highlighted. This is more complicated, and that's what we're going to build up to today. But here, x times 2x is 2x squared. X times x is going to be xy. And move down here, 2 times 3x is 6x. 2 times 5 is 10. So hopefully that's ringing some bells for you with the distributive property. And now in your spirals, take a second to use that distributive property to do these problems. Again, we're going to be in your spiral here. So pause the video and try to do the distributive property, and then come back to check your answers. All right, so we should have all of those. This is called factored form, just to make sure we're getting our vocabulary in. And then this is simplified. Okay. And when you have terms that have both x and y, or p and w, or something like that, we're always going to go in alphabetical order. All right, let's look at this next one. You don't need to draw this. It says write the area as a product. Product is when we're writing our length times our width, and as a sum. That's the inside. for the composite rectangle shown. So here you can see I have 1, 2, 3, 4 x's, and then 1, 2, 3, 4, 5. So that's going to be 4x and 5, and means plus. And then on the other side, I have 2x, and then this is 1, 2, 3. So my product, if I'm writing as a product in factored form, that's going to be the quantity of 2x plus 3 times the quantity of 4x plus 5. Then the sum is the inside. So you can see here, this is 8x squared. I'm going to change colors now. This is 12 x's. This is another chunk of x's over here. And that's, you can look here, I had 5 by 2x, so that's going to be 10 x's. And then last but not least, I'm going to change colors again. This is 15. So I can add that all up. So my sum is going to be 8x squared, plus I had 12 x's, and I had 10 x's from the top and the side, plus 15. Then these are like terms. They're the same kind of tile. So that would be my sum when I simplify it. Okay, so hopefully at this point you're realizing drawing tiles is kind of a pain in the neck. We don't want to do it forever. So we can move to something that looks like this. So take a second to kind of take it in. Examine the following diagram. How is it similar to the set of tiles in problem 522? How is it different? So think for a second, what's similar, what's different? Hopefully you're noticing here that the dimensions are the same. So I said I had 4x here, and this represents my 4x's here. I said I had plus 5, and I have a 5 over here. You can write the plus or not. I had 2 x's on this left side. There's 2 x's here. I had 3 x's here, and there's 3 x's here. You'll also notice that the little different sections that I labeled before are already labeled here. And what I want to emphasize to you guys is that 8x squared is what you get when you multiply 2x by 4x. And 12x is what you get when you multiply 3 by 4x. So we're kind of going across from the column and the row where they intersect. And then in that space where those columns and rows intersect, you write their product. You write what you get when you multiply. It kind of reminds some people of a Punnett square if you think about science and the genes. So then here, 2x times 5 is 10x, and 3 times 5 is 15. So this is what we're going to call, or what I call, because I've used this for a long time, is a generic rectangle, because it just generalizes everything that you've done before. Your book is going to call it a table. So I often say generic rectangle, but your textbook, and on your homework tonight, will say to use a table. Okay, so now we're going to move into toolkits, and we're going to start your toolkit. We're going to finish it later, but we'll start it. So your title is Multiplying Polynomials for 7.2, so take a minute to pause the video and get that set up. Okay, I want you to label this little subsection as generic rectangles / tables. So that's what your little subsection is going to be. You don't need to write down this whole paragraph. Then take a minute to pause the video and copy down, I'm going to zoom out so you can see it, copy down these rectangles. And they don't have to be a certain size. They can actually all be big enough. You are going to need to write inside those squares, so make sure they are large enough. So pause the video to get those down. Okay. Let's start filling these in. As I was talking about a minute ago, we are going to fill in the spaces of the rectangles with what you get when you multiply the dimensions by each other. So looking at A, 3 times y is 3y, and 3 times 5 is 15. So now for our dimensions, when I write it as a product, I'm going to write one dimension, 3, that's my width, times y plus 5, the outsides. The sum is what you get when you add up the insides, so 3y plus 15. All right, B is a little bit more complicated. So I'm going to go slowly. So 3x times x. X times x is x squared. So this is 3x squared. Now I'm going to do x times negative 2 is negative 2x. Now I'm going to do 4 times 3x is 12x. And 4 times negative 2 is negative 8. All right, the product, remember that's your length times your width. So I have 3x. We always want to start with the x term. So I wouldn't put -2 plus 3x. I would always put 3x minus 2. And then x plus 4 because it's a positive 4. Now, these can be in opposite order. So you could write the quantity of x plus 4 times the quantity of 3x minus 2. That's fine. Okay, sum is where I add up the inside. I have 3x squareds. Then I have minus 2x. Then I have plus 12x. Those are going to be like terms, so I'm going to have to put those together. Minus 8. 3x squared. -2 plus 12 is going to be 10x minus 8. Okay, so that's your sum, or the simplified version. Okay, C. 2x times x is going to be 2x squared. Now I'm going to move up. 2x times 5 is 10x. -3 times x is -3x. -3 times 5 is -15. My product, my dimensions, are going to be x plus 5 times 2x minus 3. Again, those sets of parentheses can be switched. Then I add up on my inside, so 2x squared plus 10x minus 3x, because it's negative, minus 15. These have the same variable to the same power, so I have to combine them. So that's going to be 7x minus 15. All right. 4y times 6y is 24y squared. 6y times -7 is -42y. 4y times -1 is -4y. And -7 times -1 is 7. Okay, product. 4y, always start with the variable, minus 7, and 6y minus 1. Sum, 24y squared minus 42y minus 4y plus 7. These are like terms. -42 minus 4 is -46y plus 7. Now, on your homework, you won't be given generic rectangles. You have to set them up yourselves. So I want to practice a couple of those. We're going to stay in your toolkit. Okay, so we are going to do generic rectangles for these, and then tomorrow we will add on how to do this a different way. So but on your homework, you're going to do all generic rectangles. So I've rewritten A here. I'm just going to leave those up there at the top. So A is the quantity of x plus 5 times the quantity of 3x plus 2. So you might be wondering, how do I know how many columns or how many rows? And it depends on the number of terms. So you'll see in here, this has an x, so that's going to be its own column or row, and 5 will be its own column or row, and then 3x plus 2. So since I have two terms being multiplied by another two terms, or if we use our vocabulary, a binomial multiplied by a binomial, then I need something that's a 2 by 2. Okay, so and I like to make them just even. I'm going to put my x plus 5 on this side. So the x gets one column and the 5 gets one column. Each term gets its own column. Remember, terms are things separated by plus or minus signs. And you could switch these. The 3x and 2 could be on the bottom and the x plus 5 could be on the top. What I do encourage you to do is always have your kind of your x terms on the corners here because of where we're going later in the chapter. Okay, 3x times x is going to be 3x squared. 2 times x is going to be 2x. 3x times 5 is going to be 15x. And 2 times 5 is going to be 10. Now, what's different in these problems is that you are given your problem in factored form. It's already as a product. So when they say find the product on your homework, they actually mean to simplify. They're saying take this stuff and multiply to get what the answer equals, okay? So really what that means is they want the sum. So find out what you get when you add this all up. So I have 3x squared plus 2x plus 15x plus 10. Now I have like terms here, so I need to combine my like terms. And I always start with my x squared when I'm writing it from the rectangle. That way everything's already in standard form. So I have 3x squared plus 17x plus 10. Okay, let's zoom out so we can see B. B was the quantity of 2y minus 5 times the quantity of 5y plus 7. So again, this one has two terms in the first binomial and two terms in the second. That's why they're binomials. So we're going to have something that's 2 by 2. 2y minus 5. So make sure that sign goes with it, 5y and 7. Again, those signs can be switched. Okay, 5y times 2y is 10y squared. 2y times 7 is 14y. 5y times negative 5 is negative 25y. And 7 times negative 5 is negative 35. Okay, start with your y squared plus 14y minus 25y minus 35. Okay, combine our like terms. 14y minus 25y is going to be negative 11y minus 35. Again, when they say find the product, they really mean just multiply. Find the sum is what they're saying. Like what is it when you multiply these two things? What do you get? Okay, letter C, 3x times 6y minus 11. Don't let this throw you off. This has one term, and this one has two terms. So you're going to have 3x on one side, and then a column for 6y, and a column for negative 11. So 3 times 6 is 18, and then the x and the y just become 18xy. And then 3x times negative 11 is going to be negative 33x. So my answer is just when you add up those two different boxes, and those are not like terms, so you're done. Okay, D is a fun one. Oh, and something like this, we don't need to worry about standard form. All right, last one for today. I'm just rewriting it. 2w minus 2p times the quantity of 3w plus p minus 4. Okay, so this one is a binomial multiplied by a trinomial. So the binomial I'm going to put on this side, and since it's a binomial, I'm going to put 5w and minus 2p, one row for each of them. And then this is a trinomial, which means I need 3 columns. All right, 5w times 3w is going to be 15w squared. Negative 2p times 3w is going to be negative 6, and then we go in alphabetical order, so pw. 5w times p is going to be 5, again, pw. Negative 2p times p is going to be negative 2p squared. 5w times negative 4 is going to be negative 20w. And negative 2p times negative 4 is going to be 8p. All right, this is a lot. This is kind of why I like when you have a trinomial involved. I always like to use the generic rectangle or the table. Okay, 15w squared. I'm going to notice here that these both have pw's. So I'm going to put those together in my expression. Negative 2p squared minus 20w plus p. Like I mentioned before, because we have so many different variables here, we are not worrying about standard form for something that's complicated. But these have to be combined. So negative 6pw plus 5pw is negative 1, if you want to write the 1, pw, minus 2p squared minus 20w plus 8p. So the ones on your homework, you're only going to have 2 that are I think, a binomial by a trinomial, but the rest of them are going to be mostly 2 by 2s. So pretty straightforward. And then we will move on to the other half, or the last part of this lesson tomorrow.